All right, we are continuing on here with looking at theoretical probability calculations, and we're going to be moving into how to find probabilities of or, which means we want the probability that one event occurs or another occurs. So or in probability refers to one event or the other or both occurring. So in order to do that, to move on to these or probabilities, we need a new definition, and that is the definition of mutually exclusive. So we're told here that two events are considered to be mutually exclusive if they cannot occur together. So they can't both occur. So we're going to look at an example. So it says here, if I draw one card from a standard deck of 52 playing cards, it is not possible for the card to be both a heart and a spade. Therefore, the events, the card is a heart and the card is a spade, are what we call mutually exclusive. And it says we can draw this relationship using a Venn diagram. So for example, if this represents my entire deck of 52 cards, then I can have cards that are hearts, and I can have cards that are spades. But those two groups do not overlap because you can't have a card that is both a heart and a spade. So these are mutually exclusive. And just sometimes it helps when we're looking at a definition to get an example of what does not fit the definition. So really quickly here, as an alternative, maybe we were still drawing one card from a deck, but this time our two events were drawing a card that's a heart and drawing a card that's an ace. So if we think about that, heart as one event and ace as another, what we're asking is it possible to have one card be both a heart and an ace, right? For these events to occur together. And the answer is yes, right? If we look at our deck of cards, we have a card that's both an ace and a heart, and that's the ace of hearts. And so if we were trying to draw a Venn diagram representing these groups, we would have the group of hearts and the group of aces. And right here, in common, is that ace of hearts. And so whereas hearts and spades were mutually exclusive, hearts and aces are not mutually exclusive. So that just gives us a little bit better of an understanding, I hope, of the definition of mutually exclusive. And then we can use that to go into some examples. So again, these are examples of what we call or probabilities. And so we want the probability of either one thing occurring or the other or both. So here we're asked to find the probability of drawing a card from a standard deck of cards and drawing either a heart or a spade. And that's the case we just looked at. And since these two events are mutually exclusive, right, meaning that they cannot both occur together, then the probability of A or B is just going to be the sum of the two probabilities. And so if I want the probability of a heart or a spade, because hearts and spades are mutually exclusive, I can just add the two probabilities. So the probability of a heart, there are 13 hearts out of 52 cards. The probability of a spade, there are also 13 spades out of 52 cards. And so we get 26 out of 52, or 1/2. Okay, So that's for an OR probability where our events are mutually exclusive. And what I want us to do next is an example of when we have two events that are not mutually exclusive, meaning that they can both occur, okay? And so we've got some overlap. And what we're going to look at this time is drawing a card from a deck that's either a heart or an ace. So this was our alternate situation where we had events that were not mutually exclusive. So since it's possible to draw a card that is both a heart and an ace, we need to use a different formula. And so what's happening here is if we want the probability of A or B, we're still going to take the probability of A plus the probability of B, just like we did up here with our mutually exclusive events. But what happens is we have this extra piece. And so what this extra piece is doing is subtracting the probability of A and B. And what we're doing is we're going to basically subtract out any overlap that got double counted when we added the probability of A with the probability of B. And I think you can see that visually in just a second. So if I want the probability of a heart or an ace, because I know that those events are not mutually exclusive, meaning it's possible to have a card that is both a heart and an ace at the same time, the probability that I draw a card and it's a heart is the 13 hearts out of 52 cards. And so what we just did there is we looked at all 52 cards and we just added the 13 right here that are hearts. Okay. But I want the probability that I draw a card and it's either a heart or an ace. And so the probability that I draw a card and it's an ace is going to be the number of aces out of the total number of cards, which is those 4 out of 52. But you can tell that if I stopped there, I made a mistake because what happened is there was a card that got added twice. And that card was where the overlap occurred between my two events. So when I added the probability of hearts, I added the ace of hearts in there. And then when I added the probability of an ace, I added the ace of hearts in there again. So it got added twice. And so what we're doing when we subtract the and is we're taking off anything that got double counted. And so the probability of a heart and an ace, well, the only hearts and aces are the ace of hearts. So there's one of those. So that ace of hearts got added here. It got added here. And we're subtracting it back out once. Okay. And so that probability ends up being 13 plus 4 is 17, minus 1 is 16 out of 52. And you can simplify that if you want to 4 13.